In our last chapter before the DCA, we're going to look at Chapter 8, and Chapter 8 is all about similarity. Similarity is different than congruency. So last chapter, it was all about being equal. This time, it's about being the same shape, but a different size. So we'll have like a smaller and larger version. And really in this entire chapter, corresponding parts is really the name of the game. If they tell us that triangle ABC is similar to triangle DEF, it means that these parts are all corresponding or they're matching. So in this first spot is angle A. It needs to correspond or match with angle D. And then in the picture, this is how we'll know. I can see that angle A and angle D have the same matching symbol. They are congruent. This time for the sides though, if I see side AB matches or corresponds with side DE, I'll see this time AB and DE, they're not going to be congruent this time. They're going to be proportional. And their ratios is what we're going to take a look at in this section. An example that you can see is here. I have two triangles, and we're seeing that triangle RST is similar to triangle XYZ. And because of the similarity statement, now I can go with matching pieces. So for instance, angle R is in the first position. Angle X is also in the first position, so I know R and X would be corresponding or matching in there. So what I'm going to do is try to find some matching parts, matching pieces. For instance, these first two positions, RS and XY, these guys are going to match. And what we're going to do is set those up and test those ratios. And when I test each of the pairings and the ratios, I find that each time I get 5/3. And that means that the scale factor from this larger triangle to the smaller triangle is a factor of 5/3. In our next example, we're going to see that this time we have to solve for a missing side. And so I'm going to group these according to my congruency statement. This is saying quadrilateral ABCD is similar to quadrilateral QRST, meaning this first part A and the second part Q are going to be matching. They're going to have those similarities, so I've got to match those guys up. So I just chose two of the sides. I chose these two guys right here, and then my missing piece right here, and I set that up as a proportion. And then in my work, you can kind of see here too, one of the things is that cross multiplying works every single time. No matter what, I can cross multiply. So 4 times 10 divided by 5, I'm going to get 8. Another way that I like to solve proportions is kind of look at this like an individual fraction. 10 divided by 5 is 2. So what divided by 4 also gets me 2, and I know the solution is still 8. In the next section of Chapter 8, they're going to look specifically at angle-angle similarity. And what we can do is say that if we have two angles from one triangle and are congruent to two angles of another triangle, so like these two guys match and these two guys match here, then we can say that these two triangles are similar. So in a situation like this, they want us to be able to write a congruency statement. So they want us to see, and what I did was I matched up my angles. I see I have two right angles here, so I put these as matching colors. And then I chose these two guys right here, both had 64. So meaning that these two are going to correspond, these two correspond, and then these two correspond. So when I write out this similarity statement, I have to have matching pieces. So I chose to go C first, which matches with K. So K has to lead that statement as well. So really, again, it's all about those matching pieces. In the third section of Chapter 8, they talk about side, 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 and side, angle, side similarity. Remember, not congruence, they're talking about similarity. So in this first one, they're telling us that if these sides correspond to each other, and I can set them up as those proportions or those ratios, and all of these ratios are proportional, then I can make that congruency statement and say that they are, not congruency, similarity statement. Make that similarity statement. And side, 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 all of these sets then are proportional. Then I know that I can say they're similar. The next one is side, angle, side. And in side, angle, side, I'll have a set of sides that I'll say is proportional. I'll have a set of angles that are congruent, And then I'll have a second set of sides that are also proportional. So you can see where I get my side, my angle, and my side. And when I have that, I can make a similarity statement. Last but not least, in chapter 8, we're going to take a look at this first theorem, and it's all about this, again, proportionality. So they use this proportion this time to talk about some parallel lines. So if I've got this little bisector here that's kind of coming in here, and we're talking about parallel lines, then I can make some assumptions about these segments. So I can say that these two pieces here and these two pieces here are going to be proportional. So if these are parallel, then they're proportional. And then in the converse of that, it's talking about just that in reverse. That if I can say that these guys are proportional, then I can assume these are going to then be parallel. Okay? So an example of that, they give us some information. This is our given. We're given that these guys are parallel, and we're giving some segment measures. So they want to know, what is this missing measure? And I know that because these guys are parallel, I can set these up as a proportion. That these guys and these guys will be able to come together as a proportion. So I did that. I wrote the segments here as well and matched my colors so you could kind of see where pieces go. And then I filled in my proportion. So when I rewrote that to solve, again, you can always cross multiply. I could have taken 10 times 12 and then divided by 8. But for me, a lot of times I just don't have a calculator handy, so I tried to simplify. I divided here by 2, and then I saw that 4 goes in there 3 times. So 5 times 3 is 15. And we're going to practice solving a lot of proportions so you get really good at doing that.